Okay, I hope I'm audible to all students who are attending this lecture of Mathematical Methods for Economics, Part 1. We intend to start with a new topic within this course. This is called as linear algebra. This is called as linear algebra. Okay, it's a completely new topic within our course. And formally, this is chapter 12, chapter 13, and chapter 14 of the book, which I prefer to follow for the lectures, which is Sater and Hammond. Okay, so this is linear algebra, which is chapter 12, 13, and 14 of Sater and Hammond. Today in the lecture, we intend to start with the topic. The subtopic is matrices, or we can write matrix algebra. Within linear algebra, this is the subtopic, and you will find this topic in chapter 12 of Sater and Hammond. Okay, so I expect students to know a bit of matrices from high school mathematics. Okay, although we will be doing all what we have done in high school along with this mathematical methods for economics course. Okay, so let's quickly look at what are matrices. So let's look at the definition of a matrix. So a matrix is a rectangular array. A matrix is a rectangular array of numbers considered as an entity. It is a rectangular array of numbers considered as an entity with m rows and n columns. The m cross n matrix is of the form. The m cross n matrix is of the following form, so we denote it as matrix A. This matrix has m rows and n columns. So A11, okay, which denotes the first row and the first column. A12 denotes the first row and second column. I can stretch it to how many columns, guys? We have n columns. So A1n. So A1n denotes the element in the first row and nth column. On similar lines, A21, second row and first column. A22 means second row and second column. And I can stretch it to A2n, the second row and the nth column. And likewise, I can stretch it to how many rows? We have m rows. So AM1, mth row and first column, mth row and second column, and then we have mth row and nth column. So this is our m cross n matrix. Okay, so we can write that in particular, Aij denotes the element. Aij denotes the element in the ith row and jth column. Okay, so I hope students are clear. If I quickly give you an example, suppose I give you a matrix hypothetically, which is 3, comma minus 2, comma 5, comma 8. If I ask you what is the order of this matrix, very simple. It has 2 rows and it has 2 columns. So the order of this matrix is 2 cross 2. if I give you another matrix which is -1, 2, √3 and 16, okay, if I ask you what is the order of this matrix, it has only one row, but how many columns? 4 columns. So the order of the matrix is 1 cross 4. So quickly revising with all the students before I erase all of this off. When we talk about a matrix, it is a rectangular array of numbers. It can be alphabets, it can be names also. Like I can make a matrix of all the students who are attending this lecture. So matrix not necessarily consist of numbers, it can consist of alphabets, words also. But when we are doing the mathematical methods for economics course, we are more interested in numbers. Okay, with m rows and n columns, you can see the m cross n matrix on your screen. In particular, Aij denotes the element in the ith row and the jth column. And two examples which I have done. One is a 2 cross 2 matrix, another is a 1 cross 4 matrix. So erasing all of this off, let's move forward. Okay, so now let's write what is meant by a row vector. So you can write a note. Let's write a note. Within the note, the first point, a matrix with only one row, a matrix with only one row is called a row vector. A matrix with only one row is called the row vector. Guys, we will be doing vectors also in our lectures, but it's coming up right now in the matrix lecture as well. Then we have a matrix with only one row, it's called a row vector. Okay, and a matrix with only one column, a matrix with only one column is called a column vector. A matrix with only one column is called the column vector. So far it's clear to all students. Okay, let's do a practice question. All students write this practice question. This practice question is based on building a matrix. Okay, so construct a 4 cross 3 matrix. Construct a 4 cross 3 matrix when its general form is given as A is equal to Aij, which is 4 cross 3, and Aij is given to us as 2i minus j. Okay, so we need to construct a 4 cross 3 matrix, guys, when this is the information which is given to us. Okay, so let's work this out. How will the 4 cross 3 matrix look like? Now it will have 4 rows and 3 columns. So it's going to be A11, A12, A13, A21, A22, A23, A31, A32, A33, A41, A42, A43. You can clearly see this is a 4 cross 3 matrix. Okay. Now in general, we are given Aij is 2i minus j. So can we calculate all the elements? A11 will be 2 into 1 minus 1, which is 1. A12 is going to be 2 into 1 minus 2, which is 0. Okay. A13 will be 2 into 1 minus 3, which is minus 1. And likewise, you all can calculate the other elements. A21 will be 2 into 2 minus 1, which is 3. Okay, and then I can calculate further elements on the right hand side of the screen. A22 will be 2 times 2 minus 2, which is 2. A23 will be 2 times 2 minus 3. A31 will be 2 times 3 minus 1. A32 will be 2 times 3 minus 2, which is 4. Okay, A33 will be 2 times 3 minus 3, which is 3. A41 will be 2 times 4 minus 1, which is 7. Okay, A42 will be 2 times 4 minus 2, which is 6. And A43 will be 2 times 4 minus 3, which is 5. So guys, if I write the matrix, on the top I am erasing the note now. And we can quickly write what is our final answer for this particular question. Now, I know that students have done these type of questions in high school, but I am just doing it for revision. So our matrix A has come out as 1, 0, minus 1, 3, minus 1, then we have 3, 2, 1, then we have 5, 4, 3, and then we have 7, 6, 5. So this is our 4 cross 3 matrix and the answer for this question. Okay, so hoping that students are clear with this. Okay. Okay, erasing all this off. Our next heading now is square matrix. Our next heading now is the concept of square matrix. So if my M is exactly equal to N, if number of rows and number of columns are exactly equal, so that the matrix has the same number of rows and columns, it is called a square matrix. It is called a square matrix given by, so guys, we can quickly write a square matrix. So our matrix A will now be A11, A12 dot 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 A1n, A21, A22 dot 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 A2n, and I can stretch it to AN1, AN2 dot 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 ANN. Okay, so you can clearly see it is an N cross N matrix now. It has the same number of rows and columns. Okay, and then guys, you can clearly see what is this. This is the main diagonal of the matrix. Okay, this is the main diagonal of the matrix A11, A22, A33, A44 dot 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 ANN. So all of us can quickly write a note. If my matrix A is equal to Aij, which is N cross N, then the elements A11, A22 dot 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 ANN constitute the main diagonal of the matrix. They constitute the main diagonal of the matrix. So hoping all students are clear with this. Okay, now erasing this off, let us now look at the concept of matrix multiplication and matrix operations in general. Okay, so our heading now is matrix operations. Okay, again, all students are familiar with this, but we are quickly doing a revision. So matrix operations. So first we have equality of matrices. Equality of matrices. Okay. So if my matrix A is equal to Aij, which is a M cross N matrix, and my another matrix B is equal to Bij, which is M cross N, are two M cross N matrices, then A and B are said to be equal provided Aij is exactly equal to Bij for all I going on from 1 to M, and for all j going on from 1 to M. Okay, so we can write, thus matrix A will be exactly equal to matrix B if they have the same dimension, if they have the same dimension. That is very important, guys. If two matrices do not have the same dimension, you cannot have the two matrices being equal. For two matrices to be equal, they should have the same dimension. That means they should have the same number of rows and columns. Okay, and if all their corresponding entries are equal, if all their corresponding entries are equal. So two matrices are said to be equal if both of them have the same dimension and their corresponding entries are equal. Second thing, guys, addition and multiplication. Addition and multiplication by a scalar. All students should know what is a scalar. A scalar is a real number. Addition and multiplication by a scalar. This is the second matrix operation. So if my matrix A is Aij, which is M cross N, and my B is Bij, which is again M cross N, then define the matrix A plus B as Aij, which is M cross N, plus Bij, which is again M cross N, which I can write as, you just add up the corresponding entries Aij plus Bij times M cross N. So when we are adding two matrices, we are not doing anything. We are just adding up the corresponding entries. So A plus B is nothing but Aij plus Bij, and this will also be a matrix of the order M cross N. So hoping all students are clear with this. This was part A. Within the second point, part B. If alpha is a real number, then define alpha times A as alpha times, what is A, guys? Aij, which is M cross N. And this I can, now if I am multiplying a matrix by a scalar, what is the scalar in this case? The scalar in this case is nothing but alpha, which is a real number. So if I am multiplying a matrix by a scalar, it means I am multiplying all the elements inside the matrix by that scalar. So I can write it as alpha times Aij, which is M cross N. So quickly revising with all students, what you can see on your screen before I erase it off. We have done two matrix operations till now. Equality of matrices. Two matrices A and B are said to be equal if they have the same number of rows and columns and if all their corresponding entries are equal. Second matrix operation, addition and multiplication of the matrix by a scalar. So this is by a scalar. Please correct it. This is addition and multiplication by a scalar. So if we have two matrices A and B of the order m by n, then addition of two matrices is nothing but addition of their corresponding entries. Again, guys, you can add two matrices only if they have the same dimension. If two matrices do not have the same dimension, you cannot add them. Second, if alpha is a scalar, which is nothing but a real number, then alpha times A will be nothing but alpha times Aij, which is m cross n. That means if you are multiplying the matrix by a scalar, you are multiplying every element of that matrix by that scalar. So hoping all students have understood the first two operations. So erasing it off the screen and let's move forward. So all students can write this. Rules for matrix addition. Rules for matrix addition and multiplication by scalar. Rules for matrix addition and multiplication by scalars. So let's look at these rules one by one. Again, I hope students have done this in high school mathematics. It's just a revision for especially those students who are completely non-math students. So for them, it's a new thing. For others, it's going to be a revision. Okay, so we can write let A, comma B and C be arbitrary. Let A, B and C be arbitrary m cross n matrices. Okay, and let alpha and beta be real numbers. Let alpha and beta be real numbers. Okay, let 0, you can see it's a dark 0. Let 0 denote the m cross n matrix consisting of only zeros. Consisting of only zeros called the zero matrix. So all students should know what is a zero matrix. A matrix whose elements are all equal to 0 is called a zero matrix. Then we have the following rules. Then we have the following rules, which you can see on your screen. The first rule is the matrix addition is associative. So A plus B का addition with C is equal to A का addition with B plus C. So we can say that the matrix addition is associative. Okay, the matrix addition is also commutative. So if you add A plus B or you add B plus A, it is going to give you the same result. Okay, then matrix A plus the zero matrix is equal to the zero matrix plus the matrix A will give you back the matrix A. That means if you add zero matrix to any matrix, you will get back that matrix itself. So you can say that zero matrix is the identity for addition. Zero matrix is the identity matrix for addition. Okay. Then a matrix, if you add it to its negative, you will always get, or I can write it as minus of matrix A plus matrix A, and that is going to give me the zero matrix. So I can say, guys, minus A is called the additive inverse of matrix A. 0 is called the additive identity for matrix A, and minus A is called the additive inverse. Because if you add A with minus of A, or if you add minus of A with A, you will get back the zero matrix. Fifth property, alpha plus beta times the matrix A, where alpha and beta are the real numbers. So this will be nothing but alpha times A plus beta times A. Okay. And similarly, we have alpha times the matrix A plus B. Alpha times the matrix A plus B will be alpha times the matrix A plus alpha times the matrix B. So these are the 6 rules on your screens, okay, which specify the rules for matrix addition and multiplication by scalar. Matrix addition is associative, it is commutative. 0 is the additive identity for matrix addition. Minus A is the additive inverse for matrix addition. And the fifth and the sixth rules are that if you multiply alpha plus beta with the matrix A, where alpha and beta are real numbers, you will get alpha A plus beta A. So it's distributive. And alpha times the sum of two matrices will be alpha A plus alpha B. So hoping students have understood this. Okay. Okay, so we now do some practice questions based on the concepts we have done so far. Okay, so let's look at these practice questions. So question number 1, when is 3 t minus 1, 2t and u, when is this matrix equal to the matrix T, 2v, u plus 1 and t plus w? So guys, basically we need to find the values of t, u, v and w such that the two matrices are equal. So very simple. You can see this is also a 2 cross 2 matrix. This is also a 2 cross 2 matrix. When will they both be equal? When the corresponding entries are equal. That means my 3 should be equal to t. Okay. T minus 1 should be equal to 2v. T minus 1 should be equal to 2v, but t is 3. So I can write 3 minus 1 is equal to 2v, which implies 2 is equal to 2v, which implies v is equal to 1. 2t should be equal to u plus 1. Okay. So 2t should be equal to u plus 1, which implies what is t? 3. So 2 times 3 should be equal to u plus 1, which implies 6 should be equal to u plus 1, which implies u is 5. Okay. And then last thing, u should be equal to t plus w. What is u? 5. What is t? 3. So what will the value of w be? 2. So answer for this question is t should be equal to 3, v should be 1, u should be 5 and w should be 2. So hoping students have understood this. Okay. Then let's look at the second question. If the matrix A is equal to 1, 2, 0, 4, minus 3 and minus 1, and my matrix B is equal to 0, 1, 2 and 1, 0, 2. The question asks us to compute the following. So compute A plus B, compute 3 times A, compute minus half times B. This problem is exactly picked up from Sitsater and Hammond. Okay, so if we quickly solve part A, matrix A plus B means what, guys? We are adding up 1, 2, 0, 4, minus 3, minus 1, plus 0, 1, 2 and 1, 0, 2. That means we are adding the corresponding entries. 1 plus 0, 1, 2 plus 1, 3, 0 plus 2, 2, 4 plus 1, 5, minus 3 plus 0, minus 3, minus 1 plus 2, 1. Okay. Similarly, 3 times A will be, you can see 3 is a scalar. Okay. So 3 times A is 1, 2, 0, 4, minus 3, minus 1. So how do I solve it? I multiply all the elements by 3. So 3 into 1, 3. 3 2s are 6. 3 zeros are 0. 3 4s are 12. 3 into minus 3, minus 9. 3 into minus 1, minus 3. And on similar lines, minus half into the matrix B will be minus half into what is the matrix B, guys? 0, 1, 2, 1, 0, 2. That means I multiply all the elements of matrix B by minus half. So I get 0. Minus half into 1, minus half into 2, minus 1, minus half into 1, minus half into 0, 0, minus half into 2, minus 1. Okay, so hoping all students have understood the second question as well. Okay, and now guys, homework for all students for this lecture. I request students to write the homework, do the problems, from section 12.6, Sitsater and Hammond, page 421 and 422. So do the problems. These are very simple problems. You will not need my help. These are very simple problems for you to solve. So do these problems, section 12.6 of Sitsater Hammond, page 421 and 422. So guys, this is where I stop in this lecture. I hope all students have enjoyed this lecture. Any doubt, you can unmute your mics and ask, or you can call up, or you can mail me your doubts at divineschooloфeconomics@gmail.com. So this is where I